All right, so an angle is where two lines meet, right?
Okay.
So if you have two lines, let's say this is one line and this is another, the point at where they meet forms what we call an angle, right? So now that point, the angle could be around here, right? That's an angle around there. That's an angle in here as well. This is one line. That's another line. This is an angle. I was trying to draw a 90-degree. That's a line, one line. That's another line. And this is a 90-degree angle here. Point is, an angle is where two lines meet, right? You have one line here. And if you have another line that comes and meets it right here, an angle is formed right there. Now, angles are classified based on the range in their size. And this classification that we're going to look at is more for you to be able to understand the technical language. So for example, if you are given a question and the word acute or obtuse is used, you know exactly what that means, right? So you should know what that means. So that's why we're going to sort of go through the different types of angles, even though it may seem a little basic, all right?
Okay, no problem.
So there are 5 types of angles. Put the point in the middle. Some space issues now. All right, so I'm going to just use a highlighter to highlight the point where the lines meet, just to make the point that an angle is where two lines meet. All right, so that's where two lines meet. So we have an angle here, right? So that's where those two lines meet. We have another one here, one here, this one. I've already drawn that one. And underneath could be an angle as well. But for what I am going to be speaking of, I'm just going to use the outer angle. Now, we already know that this one right here is what we call a right angle triangle, right?
Yes.
So this is right angled. I'm just going to use the shortening abbreviation for right angle. And right angle triangle are just 90 degrees. Nothing more, nothing less. So once you hear it spoken of to say it's a right angle triangle, you know straight off the jump that it's 90 degrees. The other one that should be fairly familiar is this one right here that is a straight angle. And again, a straight angle, one of the easier ones again, it measures just 180 degrees, all right? Now up here, top left, is what we call an acute angle. And acute angles are less than 90. So less than 90 degrees. So I'm going to use just another color here to just, no, let me use, to just dot in where in this particular angle, where the 90-degree line would be, right? So if this were a 90-degree, it would be where I have that dotted line, right? Now an
Okay.
acute angle, so this is a dotted line and this would give us 90 degree, yeah? An acute angle we're saying is any angle that measures less than 90. So an acute angle would be any angle between this dotted line and this line here, any angle between that, because the dotted line represents 90 degrees. And so any angle between this dotted line and this one here would represent less than 90 degrees. So it would be, could be any one of these, any one of these, any one of that. Do you understand? Once it is less than 90 degrees, it's an acute angle. Follow so far?
So far.
The other type of angle, this one here, bottom left, is what we call an obtuse angle. An obtuse angle. Obtuse angles are greater than 90,
But less than 180.
but less than 180. But less than 180. So again, I'm going to just draw what a 180 would be. Let me just move this over a little so I can have space. So our 90 line would be here. I'm putting it in broken line in purple. So this would be your 90 line. So of course your obtuse angle would be anywhere behind this 90 line because it's greater than 90, but it has another boundary, which is this would be your 180, your straight line angle. It is going to be less than 180. So it's going to be anywhere between these two lines here. Any of these angles, right? Could be an obtuse angle because it is greater than the 90-degree angle, but it is less than a straight line angle. All right. And the last one is a reflex angle. And a reflex angle is greater than 180, but less than 360. All right. So again, I'm going to just draw a dashed line for our 180. For this, it would be somewhere like this. This line is lean, so I'm going to have to just. So this would be what the straight line is, right? To represent a 180 degree. So a reflex angle is greater than this 180. So it comes somewhere in between here. It's greater than 180, but it is a less than 360, meaning that it doesn't make 360 would mean it is a complete, well, I won't call it circle, but the angle comes all the way back around here. So it's greater than the straight line, but it has not gone back to the origin. It has not gone back where the angle started. Because if it go back where the angle started, that is now 360 degrees, right? So it's somewhere greater than the 180, but less than a full revolution, a full extension of the angle. Greater than one complete turn. So if this is a point, say this is a point right here, and you have your angle, this would be what 360 looks like. 360 would be coming all the way back around to where it began. That would be 360, right? So we're saying if this angle starts here, over here, let me just highlight it. So if this angle starts, here, where this line is, 360 would be coming all the way back to this line. So we're saying for this, the reflex angle, it's greater than a straight line angle. So it's greater than 180, but it's less than 360, meaning that it doesn't come all the way back to this line, right? It can come here, close, anywhere in between, but it doesn't come back to the starting point. It doesn't make one full revolution. All right. Questions?
No, good so far.
All right, great. So let's move on now to some properties of these angles, right? Now, depending on, just use one for a page. I have enough space. Right. So depending on, which career path you take and all of these things become important, right? So let's look at the angles around a point. All right, so this is angles around a point. So I have placed my point in yellow, if you can see it, and my angles are there. Now, when we have two lines that intersect, we have an angle that have sort of an X formation, right? Whether the X is straight way, upright, it's sideways, it lean. Once you have two lines that intersect and the angles are formed around a point, like what I show you here, the angles opposite to each other are called vertically opposite angles and they are equal. So to say that simply, what we can say is angles around a point that are opposite, they are equal. So let's express that. So this angle here up top is opposite from the one on the bottom, right? Top and bottom, it's opposite. So these ones are equal. So I'm going to label this A and A, right? So angle A, the A's are equal. So angle A is equal to angle A. And then these ones over here, I'm gonna call them B, B and B, they are also equal as well, right? So they're opposite to each other, vertically opposite, and they are equal. So if you know the value of this one, for example, if you know the value of this one here, then you automatically know the value of this one because you can just apply the principle, the rule that says, you know, when angles form around a point, vertically opposite angles are equal. Any questions on that?
No, it's good so far.
So far, this is revision for you, so
It's part of it.
yeah, but everything needs revision, yeah. All right. Our next one we're going to look at is angles on a straight line. Again, these are just properties of angles, so that when you see them, when we start doing other things now, it's not so difficult. So we know that when you have a straight line angle, right? It's supposed to be equal to 180 degrees, right? We said that before. Angles on a straight line equal to, well, when two lines meet to form a straight line, the angle that is formed measures 180. It therefore means that if multiple angles are on a straight line, it still measures the sum to give you 180. So if I'm to have this angle A, that angle B, and that angle C, A plus B plus C is going to be 180 degrees. If I go ahead and I have same angle on a straight line, right? But this time, instead of having three angles, I have, what should I, four. The rule still applies. As long as they're on a straight line, it must sum to 180. So if we have A, let me put D, E, F, G, we can say D plus E plus F plus G is equal to 180 degrees. Clear?
Okay.
All right. Let's look now at alternate angles. I need just a few minutes to do some drawing here. Drawing these things too big. I can't help myself. I don't know how to draw them smaller. right, so I have attempted to draw. All right, here we go. So now we have our alternate angles. Now, this you can call alternate angles or Z angles, right? So I don't have enough space to write it because I full up my something. But they're called alternate angles or Z angles. I like to call them Z angles just because it's easier to appreciate. It's easier to remember because we know what a Z is. So let's see why they're called Z angle. So usually they are made when you have two parallel lines. So parallel lines are lines going in the same direction. And if you notice, I put the arrowheads on them to show that the lines going in the same direction. And those two parallel lines are cut by one transverse line. Transverse means slant line, right? So under those conditions, you will have a Z angle being formed. Now the Z angle is exactly how it sounds. And I'm going to highlight the Z on each of them. So if you notice, if you go right there, so right here, so you see that Z right there?
Okay.
That Z is sitting properly like how we know a Z should sit. But sometimes you will find them on them side and on them belly, but it is still a Z, right? So in this case, you have that. Our Z is right here. And in this case here, the Z is right here. All right. So now we see why they're called Z angles. So what I like to tell students is once you've identified the Z, a Z only has, like a literal Z, a Z only has two angles, right? One is here and one is there. And those are the two angles under consideration, right? So once you identify a Z, then the Z has two angles, and we can see I'm going to label our Z angles on these diagrams. Now I'm going to label them A and B. So you have one here, that's A, and one there, right? For that diagram, you have one here and one there, and you have one here and one there, right? So those are the Z angles. The relationship between these Z angles now is that they are equal. So whatever the value of A is, it is going to be the same as B, all right? So I'm just going to find a little space to put Z angles are equal. So in our case, where our Z angles are A and B, we can say angle A is equal to angle B. Clear so far?
Okay.
All right. So one thing I want you to realize though is that when we look at the Z angle situation, we notice that the angles are on opposite side. That's why they're called alternate angles, right? One is on the bottom for this one is on the top, right? This one is under the bottom, this one is on the top here, and so on and so forth. I make that point because our next type of angle is going to be what we call a corresponding angle. All right? And they are formed in a similar situation when you have two lines cut by another, right? So you have a transversal and you have two parallel lines. The difference with this is that in the Z angle, you would find your Z, and then the angles will be opposite each other. But in the corresponding,
Outside of the Z.
huh?
Would it be outside of the Z?
No, it will be on the same side.
Okay.
See there? So it would be on the same
Oh.
side. So it can be either here and here, or it could be over here and over here. But it has to be on the same side. So which is why this one was called an alternate angle, because they're on opposite sides, as you can see. But on this side, on this one, they're on same side, right? So how you identify them is you identify the transversal, which is that line that cuts the two parallel lines. You identify them and then they're on the same side. So for example, if this is parallel line A, let's call this parallel line Q, and this is parallel line R. This is your transversal here, right? So you find them by first identifying your transversal. So we can say, okay, this is our transversal right here, right? And then you say on the same side of the parallel lines, right? So if this is my Q, I can look on the say this is the right side of the Q. So on the right side of Q, I have angle A, and on the right side of R, I have angle A. So these two angles will be equal. They're corresponding. They're on the same side of the transversal. All
Okay.
right. So that's what it looks like. And we'll work some examples so that it can be easier fleshed out. All right.
Okay.
Any questions with that one?
No, good so far.
All right. The last one now that we're going to look at is co-interior opposite angles. All right. Now, as you can see, we have the word interior here, and I like to just go very basic with these things. What does interior mean?
Inside.
Interior mean inside. Great. So let's use that and see. So let's draw my line. So I have two parallel lines here, and then I have a transversal, right? Now, co-interior means inside of, right? So it's either it going to be the angle, two angles that are inside this section, this inside part of the transversal. Because when the transversal cuts the two parallel lines, you have what I'm going to call two inside, right? So you have this inside over here, and then you have this inside over here, right?
Yes,
So the co-interior angle have to do with these inside portions of when the transversal cuts. All right. So the rule says now that co-interior angles, if you add them, they're equal to 180 degrees. So if you have co-interior angle A here and co-interior angle A there, right? These are two angles on the inside. They're equal to 180 degrees. So A plus A is equal to 180 degrees. And well, before I go there, and another one is this A, well, not, I'm going to call that B. B over here, this is also inside, right, of the two parallel lines cut by the transversal. So B and B, if you add them, you're going to equal to 180 degrees. That makes sense to you? Shana gone? What is this here? Amoy? Amoy, you okay so far? You're following along?
Yes, miss.
Okay, great. So these are the rules. So we have 5 rules, I think, 5 or 4. 1, We started off with angles around a point, saying that, well, not, well, angles around, well, 2 points to make here. All the angles around a point sum to 360, right? So if we should take A degrees plus A degrees plus B degrees plus B degrees, that is equal to 360 degrees. And also, if we should take A degrees plus A degrees, which are the opposite vertical angles, they're equal, as in they measure the same, sorry, not A plus A equals to A. So they measure the same opposite around a point. So A and A are opposite around the point, so they are equal, meaning that they literally have the same size. B and B are opposite around the point, so they are equal as well. So B is equal to B, right? So that's the first property. The second one is that all angles on a straight line sum to 180 degrees. Doesn't matter how much of them you have, as long as they are on a straight line, they sum to 180 degrees. The third property we said had to do with the alternate or the Z angle. That means that if you have two parallel lines, which we see here, both moving in the same direction, and they are cut by a transversal, which is this line here. I'm gonna just do it in green. This one here, this is a transversal. In each of these examples, they're cut by a transversal. You will have what we call a Z angle being formed. And I have highlighted in yellow how the Z angle forms. The rule is that Z angles are equal. They're equal, same size. Then we look at complementary and corresponding angles, sorry. Corresponding angles, again, you have a transversal and you have two parallel lines. Complementary angles find themselves the same position on opposite sides of the transversal. So this is what the corresponding angles look like. And we just did the interior angles, the inside angles. Under the condition when you have two parallel lines cut by a transversal, you have interior angles on either side of the transversal. If you sum them, you should get 180 degrees. All right. So those are our general rules for our properties of angles. So we're going to go ahead now and just focus on working some questions before we move on to our next, sort of our next, I want to call it topic, but next section under this topic. So I have started to put down some questions for you guys, so you can take them off because I want to move on and write some more. So you can just jot them down and just start to work them. And we're going to come back and work them together just to make sure that everybody understands and we're good to go before we move on, all right?
Okay.
You guys took down these three already?
Yes, miss.
Am I?
Yes, miss.
All right, let us. Yes, so the point I want to bring out though when we do that is that sometimes for some question there are multiple rules that can apply, and so in working it, not because you know, somebody else works it differently, or you know, don't feel a way about how you approach it, because a lot of time there are multiple rules that you can apply to solve these problems. All right. And I know that you guys go
Okay.
to promote an exam and compare and contrast, and then you go home depressed because, you know, you feel like somebody else is something different, where a lot of times, you know, there are multiple routes to the same destination. So let's go. Also, when I work them, I am going to just put the rule or the property of the angle that we're using. When you are working your question, when you're in exams or on a test, you don't have to do that, because we're practicing, and I just want us to be very familiar with these concepts, and I want to have them reinforced. I'm just going to keep repeating them. I'm going to write them down. I'm going to say them multiple times. So just be prepared for that. All right. All right.
Okay.
So we have an angle around a point right here. So I just highlighted my point. And what we have here are vertically opposite angle. All right, are you see that?
Yes, miss. Yes,
So
miss.
this is vertically opposite angles, right? So that's what they are. So vertically opposite angles are equal. So it's A is equal to 38 degrees. It's as simple as that, because vertically opposite
Yes.
angles are equal. Clear?
Yes, miss.
For that one, great. So let's go to the other one. Let's go to this one over to our right. So we have, again, angles around a point. Angles around a point. And we can see two vertical, we can, all right, we're asked to find A and B. So I'm going to find A first. I'm going to find A first, and I'm going to say A is vertically opposite from the 57 degrees angle. So I'm going to use the vertically opposite property here, right? And because they're vertically opposite, we can say A is equal to 57 degrees, all right? Now, the other property, the other one is angle B, how to find angle B. And we can find angle B one of two ways, which both are effectively the same way, right? We can say angles on a straight line from this direction, right? So we see we have a straight line here. So we can use angles on a straight line. Well, actually, what we're going to use is angles on a straight line. So I can just put that there. So we can use this angle on a straight line with the 57 that we were given and B. So we can say 180 degrees is equal to 57 plus B, and it's 180 because angles on a straight line sum to 180. And then we would have 180 minus 57 equals to B. What does that leave us?
123.
127 degrees equals to B. Great. So you can use this angle.
127 or 123?
Are you me following?
123.
Me not
No, miss,
calculate.
I said 123.
126? What? Three. Supposed to be three.
3.
Me not calculate it, and I'm just listen to what you tell me. Yes, all right, 123. Thank you. All right. So that is one way of working it, right? Another way, which is basically the same type of way, is to use this angle on a straight line right here to say A plus B is an angle on a straight line. The thing is, we found A to be equal to 57 degrees, and so the same working out would apply, right? So I'm just showing you
Okay.
both ways because I don't want you to get nervous or uncomfortable when you consider that, you know, when you consider that they use, whether you're going to use this way or that way, sometimes you doubt yourself. So I'm just saying it for you to be aware that either way would work and either way would give you the exact same answer. All right?
Miss, what I did it both ways. I did it this way and another way.
Tell me the other
I
way.
first added both angle A, both A's, that would be 57 degrees plus
Mm-hmm.
57,
Right?
gives you 114. And
Mm-hmm.
then I said that you get 360 degrees if you go right around.
Right?
That's just, I said 360 degrees minus 114 is equal to 246. Then I divided that by 2. So
Right.
I've gotten both angles.
Okay, great.
So I've got 120.
Okay, and since the angles are opposite, right? So that could work as well, but that's a longer route, but it could work as well.
Yes.
So yeah, all right, great. So several ways to skin the same cat, right? I don't want people second guessing themselves and doubting themselves because it don't look like that is the way and all of these things. So let's go on to the last one, this one here, the one at the bottom. So I am going to work this out using, let me see, so that I can use corresponding angles here. So I'm going to use corresponding angles for this one. All right, and corresponding angles are equal. So we see we have our transverse line here, and we have both parallel lines. And again, A is on the right of the parallel line, of this parallel line, and the 50 degrees on the right of the other one. So they're corresponding angles. So A is equal to 50 degrees. Simple, simple, simple as that, right? Now, it is quite unlikely you're going to get a question where they're going to ask you to find A like this, right? But it is very likely that you will get a question where you will need to use these concepts to answer a bigger question. And so learning these concepts are critical, right? So let's move on to some more funny or fun ones, all right? So let's start. So again, I'm going to just show how I did it, and then we can work through if you did it anyway different. So I started by saying B and this 37 degrees here are interior angles. Are you seeing that?
Yes, miss.
Right? So I started off by saying B and the 37 degrees are interior angles, and the interior angles sum to 180 degrees. So I know that 180 degrees should give me 37 degrees plus B. And so 180 minus 37 equals to B. So what does that equal to?
Equals to 143.
Okay, 143.
143.
Okay. 143 degrees. So I got B from that right there, right? So B is 143 degrees. Then I can find C. I could have found C, whichever one you do first is fine. C now, I'm going to say this is angles, again, angles around a point, and this 37 is opposite to C. So this is a vertically opposite angle. So C and 37, the 37 degrees angle are vertically opposite. So therefore, C is equal to 37 degrees. All right. So that is C. We've ticked off C. We found B to be 143 degrees. And just give me a minute. Let me clear up and clean up this. So we found B to be 147 degrees, 143 degrees, sorry. And we can see that B and A lie together on a straight line angle, right? And so we know that angles on a straight line is equal to 180 degrees. It therefore means that 137, which is the size of B, because remember we had found B to be 100, no, not 137, 143.
143.
We had found B to be 143 plus A will give us 180 degrees. So A is going to be equal to 180 degrees minus 143 degrees. A is equal to 180 minus 143, 37. 37 degrees. Now, did you get those answers, Shauna? Hello? All right, nobody's there. All right, so the other way we could have worked this question.
Yes, I got those.
Great. The other way we could have worked this, yes. So the other way we could have worked this question that I'm going to just show you now is, so I started off by using the interior angle rule to find B, and then I could have found A by using the straight line rule, and C, I don't know what happened to C, and C by using the vertically opposite rule. Something is missing from this. This is what, 37, right? Using the vertically opposite rule, but there is another way I could go about finding A to begin with, right? So let's look. I'm going to use another property, another rule. So if we look at it, this is this line here, this line here, these are parallel lines, right? And this would be a transverse line, right? So then what that means for us is that we can have Z angles or complementary angles. In this case, the Z angle is what is important. Not the Z angle, the complementary angle, sorry, is what is important. So we have left, sorry. So we have left and right of this line, left and right of this line. No, lies. Left over here and right over here. What am I writing? Be foolishness, right?
So supposed to ask you which is right.
I have no clue what is happening to me. Right, so just highlight but this portion of the line, great. So we can see that this 37 degrees here, this 37 degree angle here is complementary to this angle over here. So instantly we could say 37 and this 37 plus this 37 here is complementary, right? So it means that A would be equal to 37. And we saw that when we work it out, even though we didn't work it out by using a complementary rule, we work it out by using angle on a straight line. But if you saw this first, and I'm emphasizing it because when different people look at different things, different stuff jump out at them, right? Different patterns and stuff like that jump out at them. So if you saw this first, that this is 37 and this A are complementary angles, and so they are equal, that is perfectly fine. You would have got, okay, excellent. So you would have gotten this to be 37 degrees, and then you could use it to find the angle on a straight line for B, right? And you would get the same 143, and then these would be opposite angles, right? Or somebody could decide that they're going to find this and then use it and say it's complementary to that, right? It could go plenty ways, right? Point being, there are many ways to go about, approach these things, right? So Shauna, you said you use a complementary rule first to get angle A. Okay, great. Excellent. It is correct, just the same. All right. Any questions so far?
So far.
All right. No, what did I do? Delete. All right, so let's get to our next question. Give me a minute. All right. Just kind of want the thing to be clear so I have enough space and stuff. All right, so let's go. So now we have this here. And sometimes when people look at, these things, they tend to feel as though it's very, what you call it now, it's very intimidating. But, the way I see it, it's just, taking it one, one section at a time, right? Just look at it and take it one part at a time. So let's go. All right, so 40 plus B. Forty plus B plus A is on a straight line. B, I need to find one of these first. All right, how did you work this out, Shana?
Means for the top part for A and B, I said they're on a straight line.
Yes.
And one of the angles is 40. So I subtracted 40 from 180. So I subtracted, yes, 40 from 180 and got 140 and then divided it by 2 to get angles A and B.
I listen. I hear you. I just working on something. Not mind.
Okay.
Sorry.
That's what I did for that part of it.
Give me a minute. All right. So how I approached this question was to say, this 40 that we have here is, so I need to find one of these or both of these, right? So this 40 that is right here, I said it was vertically opposite to this angle right here, right? So I know that this angle right here, because they're vertically opposite, that angle is going to be 40 degrees, right? Now, if this angle is 40 degrees, then I know that, which one of them? These, is it? This angle is 40, 40 and 40. All of these here are on a straight line. Let's use the properties and decipher, right? So we can start by saying, I'm going to start off by just highlighting a particular, let's do it this way. Can start off by using a particular.
Make it sound far from the device.
A sound far?
Yes.
Is it better now?
Yes, miss, a little better.
Okay. All right. So I'm going to start off by using the parallel lines and one of the bisector. Now, if I use this bisector here, this transversal here, if I use this one, I'm going to be searching for angle A. If I use this one, I'm going to be searching for angle B. All right. So I am going to start with, I'm going to, just for the fun of it, I'm going to use this one here. All right. So let's go with this one. And I'll come back and show you how to use the other one. Don't matter. So I start with this bisector. That is so jagged, but I don't know why I can't, my hand trembling so much when I draw in a straight line. All right, so this is what we recognize as two parallel lines with a transversal. And so we know there are several things that can happen when we have a transversal, right? One of those things is that you can either have a complementary angles. You can find Z angles or you can find interior angles, right? Now, you can go through it as a what do you call that now? Trial and error thing to see if your Z angle can help you out, to see if your complementary angle can help, and so on and so forth, right? You can go through it like that. Or if as you look at it, you spot something, that is also something that you can do as well, right? So I'm going to be using, let me see. All right, so this here, 60 right here, is going to be complementary to the angle that is right here. Now we don't have that angle under consideration, but we can have it, we can use it to help us to answer the question, right? So this 60 here is a
Complementary angle.
complementary, and it's not complementary, no, it's corresponding, right? So this 60 here is a corresponding angle to this. This angle here is corresponding to this one, right? Are you seeing that? So if you look at these two bisector, this angle is on the bottom, and it's also this one is on the bottom of the other, not bisector, parallel line, right? So we can identify this as being 60 degree right there. Are you following me?
Yes, miss.
So having found this 60, because we use the property of corresponding angles, we can then go ahead and say angles on a straight line, and I'm using this here as my straight line. Angles on a straight line will be equal to 180. So we can go ahead and we can calculate for B. So B is going to be equal to, no, let me do it the other way. So 40 plus B plus the 60 degrees that we found is going to be equal to 180 degrees, right? So B is going to be equal to 180 minus 60 plus 40, which is 100. B is equal to 80 degrees, right? Which is what? Which is what I had got when I worked it initially, which is why when I said 70,
Okay.
I was surprised. So B now would be 80 degrees. So we can say this is 80 degrees right there. So that's how we would find the B in this scenario. All right, so let's look again. Let's go again. Since we now have a B, which is 80 degree, we can, let me just clean up this a minute for you. Oh, no. Just wanted to get rid of this. Yes. So since we know, I just clean it up so that we can have some more space. We can now use angle on a straight line to find A. So what is going to be this straight line now? See that?
Yes, miss.
So I'm going to delete this over here. So since we worked it already, so I can have some space. All right, so we can say angles on a straight line is equal to 180 degrees. So it means therefore that A plus 40 plus 80 is going to equal to 180. A plus 40 and 80 should be 120 equals to 180. A is equal to 180 minus 120 is equal to 60 degrees, right? So this A is 60 degrees, all right? So let us now try to work out C. No, that's the last one that is left. So let me just clean up this, just get rid of some of these things, all right? So now I'm going to just let me get rid of this yellow as well. I'm not using that no more, not that. All right, so we're going to go with finding C, and I am going to just highlight the same part lines, right? But this time I'm going to be using this transversal, right? It's the same parallel line, but just a different transversal. So I think I'm going to use, in this case,
Z angle.
yeah, I'm going to use a Z angle. All right, so let's go. Let's see. I'm turning my head sideways to double check something. Yes, so let's say this is our Z angle right here, right? That's the Z we're working with. Now, what that means is that C is going to have to be, this is the angle that C is going to be alternate with. So I'm going to have to find that angle right there, right? This angle, however, as we can see, is vertically opposite to B angle that we found earlier. Remember that B angle? You see that?
Yes, please.
So this angle, this unknown, this angle that is alternate with C is vertically opposite to B, which is right here, which we found to be 80 degrees. So that means that this angle is also 80 degrees because alternate angles are equal. So this angle is 80 degrees. See that? This angle is 80 degrees now, and we do the Z angle business right here. So Z angles are also equal. So it means that C is also 80 degrees. Clear?
Yes, please. So far.
So far. All right. So that divide by 2 business. Nobody gonna do that in an exam and lose your marks.
Okay.
Find the property and work from the property to find, right? And as you can see, when I did this one here, I've had to find 2 angles that I was not asked for, right? Those 2 angles were not asked for, but I needed them to get to an angle that I was asked for. So it's just a matter of identifying what properties are at your disposal to use based on the information that you're given and work your way there. When you become more expert at this after practice, you'll be able to just do some of these in one step, for example, you know. But for now, you take your time and you go step by step by step. And after you've built that nimbleness, then you can do it, you know, in shorter steps. All right. All right,
Okay.
next question. All right. I don't think I worked these, so we'll be working them together. I don't think I worked any of those other ones. So let's go. Let's see. We're asked to find A and B. No. So these are the angles we're asked to find. So we're asked to find angle ABC, which is AB. So the angle would be right there, right? So what is this? DC. So this is angle ABC, all right? So we're being asked to find these corners here. So we're asked to find this first, which is angle ABC. We're asked to find this first. So by looking at it, I will say using interior angles. So A and angle A and angle B are interior. Okay, you see 2 parallel lines going here, and then there is AB is a transversal, right? So A and B are interior. So if I'm to use the interior rule, interior angles sum to
180.
180. So A and B will be equal to 180. We know A to be 90 degrees because of this little box right here. So this is 90 plus B equals to 180. That means that B is also
90.
90. All right? So this is 90 degrees, right? I'm going to just insert the value as I go along because we're going to need them to do other stuff, right? So this is here is 90 degrees. So I could have just put a little box there, but I opted to just put the 90, right? So our next, any questions for that one?
No, miss, I got that part.
Great. B, C, D now. So that is B, BCD. So we're trying to find, these are different color. We're trying to find BCD, this angle right here. All right, so again, let's consider that we have two parallel lines here. We see them going up, and this is our transversal. So I could literally carry this. You are used to seeing it, cut it all the way through and having some extras left over. But because you're seeing it without the extras, you know, you're thinking, oh, it's not a transversal, but it absolutely is. Now, once you see it like this, it should be easier for you to appreciate that this now here is a Z angle. Right? So that's a Z angle right there. Are you seeing that?
Okay.
That's a Z angle. And we see the alternate angles here, and Z angles are equal. So we know that if this is 50 degrees, then this here is also 50 degrees. Right? You get that one?
Okay.
Great. So I'm just going to put 50 here. So that's 50 degrees there. All right, next one now. So that was 90. That was found to be 50. So let's see what ADC is now. ADC is ADC. So it's this angle right here. So we're going to use just the simple mechanics of saying ADC is on a straight line right here, right? We can see that, right? It shares a straight line angle with this 50 degrees. So then we can say angles on a straight line is equal to 180 degrees. So angle D plus 50 is equal to 180 degrees. B is equal to 180 degrees minus 50, which is 130 degrees. So angle D here is 130 degrees. Got that?
Okay.
Excellent. So let's move to the next one. All right. So we have this setup right here, and we are told that we need to find angle P. So we're going to work our way a little bit before we find P. So let's start. So and at the end, you can tell me if you utilize a different way of doing it. So I started out by saying by trying to find this angle here, right? Now, because that angle is around a point, and I've put the point in yellow there, because it's around a point, I can say that it is vertically opposite to the angle 65 degrees. So because it's vertically opposite, they are equal. And so I can deduce that this angle is also 65 degrees. Agree with that?
Okay.
It don't look like it's the same size, but remember, when you see these on the exam paper, it's going to say not drawn to scale, and that's for a reason, because the angles may not necessarily look like what you think it is. There may be an angle that don't look like 90 degrees, but it is 90 degrees, and there's a reason why them say it's not drawn to scale, right? So this is 60 degrees, 65, sorry. So now that I've identified that this is 65 degrees, I'm going to go ahead and say that these are interior angles, right? Now, it's interior to an angle that we don't need to find, but we're going to find it just the same to help us find this angle here. So it's interior with this, so we know that they should sum to 180 degrees, right? So,
Can you repeat what you just said? I didn't hear you.
sorry about that, Shauna. Yeah, I was just saying that this, because this is an interior angle, is going to, they're going to equal to 180 degrees. All right, so we can go ahead and find this angle here by saying interior angles would sum to 180 degrees. So our 65 degrees plus our x angle is equal to 180. X is equal to 180 minus 65. What does that give us now? That looks like 125 or something. 115. 115. 115 degrees. So this mystery angle right here, this mystery angle is equal to 115. I'm going to just put it in 115 degrees. So now, having found all of that, I can now find the angle that I was asked to find, which is angle P. Because we see that angle P is around a point with 150 degrees, and we know that all angles that are around a point sum to 180 degrees, right? So angles around a point would sum to not 180, 360 degrees, right? So it means that if we add our angle P to 115 degrees, we should get what? 36. I keep writing 180. We should get 360 degrees. So P is equal to 360 degrees minus 115 degrees. Should be a reflex angle. Should give you 245 degrees. So that's what P is equal to. Follow? Any questions?
No, miss.
Did you get that?
I was almost finished when they came back.
Oh, so why you never tell me, say you never ready for me?
Miss, I got the 115. I was just about to work the part of the angle.
Okay. Okay, understood. All right, so you got the 115, so that means you are on the right track then, right? All right, so now, since we that's for angles only. Can I say only? Yeah, that's for angles alone. So we're going to now move on to properties of angles in polygon. So that's what we're going to be doing next. Oh, there's one more. Is there one more? Yeah. There's one more. All right. So let's go. For this one, how do we do this one? Oh, all right, so this one is easy. So we have here angles on a straight line. This is a straight line, if we can see it. So we can easily see that angles on a straight line is equal to 180 degrees. So that means that our angles that are on a straight line here should also sum to 180. So 60 plus y equals to 180. Y equals to 180 minus 60, 120 degrees, right? Great. So we found this to be 120 degrees. So to find x now, we can do it one of both ways. We can either do the complement, no, we can either do
By the vertical.
the corresponding angle, or we can do the Z angle, the transverse angle. What you say we can do the vertical?
Yes.
What is vertical?
Y. All right. Down the bottom, we have Y angle, measures 120 degrees.
Yes.
You got the angle. Let me put it right.
Opposite.
Miss?
They say the angle opposite to it?
Opposite to it, yes, would be measured to 180 degrees, 120 degrees also.
Yeah. Yes.
And the other side, we have the 60 degrees, you know that one is also 120. It's also 60 degrees.
60.
Opposite to the 60 degrees is 60 degrees.
Yes.
Then you say the interior angles, remember interior angles measure 180. So the interior angle to angle 60 that we just found would be, yes. And on the other side, we have 120.
Because you do angles on a straight line here.
Yes.
Right. So that's why I say you can either do Z angle, you can do, well, you did the interior angle, which is also fine. We can corresponding angle as well, because for Z angle, this is the Z angle that you did just now. So what the Z angle would be about? Oh, sorry. Give me a minute.
Your battery's running low.
Yeah. I'm gonna need to do it before it. Right. So we're saying there are multiple ways that we could go about doing it. So having found Y to be 120 degrees, we know that because they are around this point here that I have put in yellow, then the vertically opposite angle, which is this angle, would also be equal to 120 degrees, right? So we can just say that this is 120 degrees. The same is true for the angle vertically opposite to the 60 degree. So this one is also 60 degree. Having found those two angles, there are several ways we can go about finding the X angle right here. The first way we can use, let me just erase this so we have some space. The first way we can use is by using interior angles. First way. So interior angle would say to us now that everything inside here, the angles inside here are summing to 180. So it would mean that this angle here, which is not the angle we want to find, but it will help us to find X. This angle, I'm going to call it question mark. So our question mark angle plus 120 should give us 180, which means that our question mark angle is 180 minus 120, which is 60 degrees, right? So this is 60 degrees as well. So I can take out my question mark, and instead I can put 60 degrees because I have found it. I'm going to just highlight it because it's an angle that we just found. It wasn't given, all right? And once you have the 60 degree, you can then just say that these angles are on a straight line. So your 60 degree angle angles on a straight line. We know that your 60 degree angle and your X angle is on a straight line. So X plus your 60 degrees angle is equal to 180. X is equal to 180 minus 60. It's equal to 120 degrees, all right? So that's the first way that we can work it, right? We're going to work it a second way now. That second way would mean we still need to find these two angles, which we did by saying that they were vertically opposite. But in this second way, we are going to utilize the principle of a Z angle. So after finding this 60 degree here, we could say that this question mark angle and this 60 degree angle are alternate angle. They are Z angles, and so they're equal, and so it's equal to 60 degree. Well, it's equal to 60 degree. Now, bear in mind that it's the same 60 degree that you got when you worked with the interior angle way. So the answer is correct. It's just that you don't have as much working out to do. And you would get this angle to be 60 degree, and then you would work out the angles on a straight line, just like we did here. And you should get the same 120 degree. All right, so that's the second way that we can work it. Now let's look at the final way that we're going to work it. What happened? All right, so let's look at the final way that we can work it now. Now, again, that final way requires that we still would have found one of these two. And in this case, it would have just been the 120 angle by saying it's vertically opposite from the Y angle that we had previously found, right? So now that we have that, let me just highlight our parallel lines as well as our transversal, right? Oy, I went a little, what? Took away all of it. Parallel lines and our transversals. So what you find is that we have this angle here, we have this angle here. I'm going to do it in yellow. So come on. So this angle right here in yellow, and it is corresponding to this angle here, which is our X angle. It's corresponding. So it is on top of this 120 is on top of this parallel line, and our missing angle is also on top of the other parallel line. So it is corresponding, and so corresponding angles are equal. So let me just say 120 and X are corresponding. Therefore, X is equal to 120 degrees. So it's three ways that we use to work and get the same answer, and they are all correct using different properties, right? So that is that for now. So we're going to move on to properties of angles within a polygon, particularly quadrilaterals and triangles. So we're doing that next. All right, so we're going to look at now angles in polygons, particularly, as I said, quadrilaterals and triangles. Now, we know the general rule is that angles in a triangle, they sum to how much?
180.
All right, so that's a general rule. Angles in a triangle sum to 180. So angle A plus angle B, that's B, right? Yes. Plus angle C will sum to 180 degrees, right? Now, this rule sort of, we can refine this rule, right? Somewhat. Or this rule applies, well, let me not say differently. Depending on the type of triangle, there are some things that we have to note with this rule, right? So let's take a triangle. Remember, the general rule doesn't change. The three angles in a triangle must always sum to 180. However, if you have a triangle, let me call this B, E, and F, if you have a triangle that has all sides are equal, and it is usually denoted by those little strokes through the sides to show what sides are equal. In this case, you have a stroke through all the sides. So it means that all the sides are equal. It's an equilateral triangle. And so what that means is that all the sides are equal, all the angles are equal. So it means that angle D equals to angle E equals to angle F. They are all equal. So in an equilateral triangle, because all angles are equal and all angles in a triangle sum to 180, each angle is 60 degrees. So D would be 60, E would be 60, and F would also be 60, right? 6 3 is 18. It would sum to 180 degrees, right? So that's the first principle, right? All angles in a triangle sum to 180. But if you have an equilateral triangle, which means that all sides and all angles are equal, then each angle is going to be equal to 60 degrees. Follow so far?
Yes, ma'am.
All right. The next one that we want to take into consideration is a type of triangle. This triangle is sort of lazy. Is a type of triangle that we are calling an Z. So we're calling this triangle an isosceles triangle, right? So it's an isosceles triangle. And in an isosceles, let me just write isosceles triangle. In an isosceles triangle, you have two sides that are equal. So if you notice, the strokes are only on two sides, denoting the two sides that are equal. So two sides are equal. And two base angles, which are, I'm just going to highlight it, the two base angles are also equal. So what it means then is that for an isosceles triangle, only one angle is up for consideration in terms of its size. So if we know one of these, we know the other because we know that they are equal, right? We know that they are equal. So the angle, the size of the other angle that's not equal is going to be dependent on the size of each of the equal angles, right? But the key thing to note is that the isosceles triangle, all two angles are equal, which are the two base angles. Two sides are also equal. And then you're going to have one angle that is not equal. And that is important because there are times when you will get questioned and you will get a triangle with just these two strokes on them. And you are going to have to be able to interpret what does that mean for you as far as working out your question is concerned. So in this triangle over here that has all three angles different, we call it a scalene triangle. All three angles are different, but it still sums to 180. The equilateral triangle, there's no guessing game there. All three angles are equal, all three angles and all three sides are equal. And so by default, each angle measures 60 degrees. And for isosceles triangle, two sides are equal, two angles are equal, and only one angle is left, different, right? So that is it for the angles in a triangle. Any question?
Good, so.
No question so far. All right. So let's look at quadrilaterals now. Quadrilaterals. Now, quadrilaterals, quad means what? 4. Right, great. 4. So quadrilaterals are any polygons that have 4 sides. And, you know, I stress the 4 sides, because it don't matter if it's a rectangle like this, or if it is a square. I hope that looks so squarish. Or if it is, what is this now? A rhombus. Or if it is a trapezium. It don't matter if it look like something where you never seen before, as long as it has the 4 sides only, the rule will apply. All angles in a quadrilateral is equal to 360 degrees. So whether or not it is a square or a rectangle, when you add up all 4, 360 degrees. When you add up the 4 in this one, no matter how it's shaped, 360. Add up this, even though this one look a little shape bad, still 360. Add up the ones in that, still 360, still 360. And yes, I know I am repeating it, and yes, it is for a point. As long as when you count the sides, there are only 4 sides, the rule applies that all angles in a quadrilateral are equal to 360 degrees, all right? Good. So now, so that is effectively, what you need to know to start working some questions. So I'm going to put some questions up, and I would like for you to start attempting it, and we're going to work through them. And once we're finished, that will be it for today. All right?
Yes, miss.
So let's go. So as we go through and work through some questions, you know, we will have more clarity, and we will see the types of questions that we can get. I want to put one per slide so I can have plenty space for the thing. And remember, diagrams that you get are not drawn to scale. So you can just draw them off. You don't have to start working them as yet, because I'm going to be skipping slides. So this is a rectangle, and I had inserted that in the conversation earlier. I written it because it matters. Because in a rectangle, the corners are equal to 90, right? So that's why it was important that I said that, because a rectangle, you know, opposite sides are equal, and each side, each corner is equal to 90 degrees. So that definitely would help us when we are, that would definitely help us when we are working out our stuff. That's why I had put that there, that this is a rectangle. So let's start then. So I am starting, and you may have started somewhere differently, but I am starting here with this triangle. So I'm starting with this triangle right here. And I'm starting with it because I see these two strokes here that will tell me that, you know, the angles, it's an isosceles triangle. So the two base angles are equal. So I know that this angle right over here, which I have a question mark with, it's equal to the 80-degree angle right here. And because of that, I can easily find B. So angle B would be equal to, well, angle B is going to be equal to 180, which is the sum of all the angles in the triangle, minus the 80, which is over here, plus the 80 for this other one, right? So that's going to be 180 minus 160 equals to 20 degrees. So you got that, Shano?
Yes, miss, I got that one.
All right, great. So the next one I'm going to work now, I'm going to work C next. I'm going to work C next. C is right here. And C is easy to work because C is a part of the corner. And we know that the corner angles are equal to 90, right? So C is going to be equal to 90 degrees minus 80 degrees, which is equal to 10 degrees, right? So that's C. C is easy enough. I am then now going to work D. And I'm going to work D as a triangle. I'm going to just highlight that triangle. I'm going to work D as a part of a triangle. There we go. So we see the three angles, and this is a corner. So of course, we know that being a corner, it is equal to 90 degrees. So D, so angle D is going to be 180, which is the sum of all three angles, minus the 90 degrees that we know here, plus C, which we can use it to be 10, right? D, 80 degrees. Great, you got that?
Yes, miss, I got that part.
All right, so I'm just going to jot in some of these values. C is 10, B is, where is B? 20. Is it 20? Yes.
Yes, miss.
20, D is 80. Just because I'm going to erase this so I can, and I want to keep track of the values in case I need them. All right, so let's go ahead and now work E. Where is E? E is right here. So I am going to work E
On a straight line.
as angles on a straight line. All right. So this is what that straight line is. That straight line is all these angles right here. So angles on a straight line. So angles on a straight line is equal to 180. That means D plus B plus E is going to equal to 180. But we found the B, well, we found the D to be 80 before, right? B, we found it to be 20. So now it's just E we need to find, right? 100 plus E equals to 180. E equals to 180 minus 100 equals to 80 degrees. All right? You got that? Great. So we found E using angles on a straight line. Then we can find F. So I'm going to find F using this triangle here. All right. So using that triangle there, I'm going to find F, and with the same thing, angles. What's happening? My thing is stuck. So, oh, my pen is stuck. It's not working. I don't know what's happening. All right, so I'll just explain. So we have three angles here, angles E, F, and 40. They should sum, because they're in a triangle, they should sum to 180. So we found angle E just now to be 80 degrees, yes? And so 80 plus 40 is 120. And when you take that away from 180, you should get 60 degrees. So F would be equal to 60 degrees. I don't know what happened to my thing. It's not working. So F is equal to 60 degrees. You can't even change slides. All right, let's find A. And so we can move on. A now, is it A? Yes. So A is easy to find as well. It's on a corner, right? It shares a corner. So we know that A plus F should be equal to 90 degrees. And we just found F to be 60 degrees. So A is equal to 30 degrees, all right? Lashana, my thing is stuck. It's not moving. Let me see something. Everything is stuck, even my Zoom. I can't click on my Zoom thing either. So everything is stuck. I'm not sure why, but I can't move anything. So we're going to leave it there for today, and I'll pick up with the other three on Monday. We'll work out those on Monday, and then go into our workout session on Monday. So
okay, no problem.
you're welcome.
Missy will be able to save the recording.
Pardon?
You won't be able to save the recording if your cursor is working.
No, man, it's going to save. But once the Zoom meeting ends, the recording usually automatically saves.
Okay, I'll see you on Monday.
Hold on, don't go.
Hold on, okay.
It's back. Well, let me see. Can I? Yes, it's back. Unless you have to go, we can do Monday, but let's do Monday because it's way past. It's 1:23. Let's stop.
It's 12:23.
Yes, it's 12:23. So we can, but we're way past. So do you want to finish or are you rather?
You can finish.
All right, let's finish. Since you have the time. All right, so let's carry on. So for this one now.
Start sharing back your screen. Your screen is not being shared.
Oh, it's not being shared.